Hello viewers, welcome back to my channel. In this session I shall discuss the optimal page replacement algorithm. The previous session I have explained about the FIFO page replacement algorithm. Now let us see the next one in the list, which is called as optimal page replacement algorithm, and we are using the same reference string here. That is, there are 20 pages in the page numbers in the reference string, and we'll use this logic. What is the logic for optimal page replacement? Optimal page replacement says that replace the page that will never be used for the longest period of time. I'll repeat, replace the page that will never be used for the longest period of time. So since in the problem statement it is given assume number of frames equal to 3, so we'll use 3 frames only here. And also we have been asked here to find out the number of page faults that are occurring. So let us start the solution. First, I'll be using a different coloring here to show the miss and hit. Page 7, not present, miss. So the first 3 pages becomes easier for us because we are going to place all these 3 pages. Next is what? There is a miss here. 0 is not there, so you will put 0 now. Next is what? Once again there is a miss here, M. Then what about? Yes, you are going to place the third page, page 1. So this is how you have filled now the 3 pages. The next one is now the page number 2. Page number 2 is not here. First you write down, yes, there is a miss. But now which page will you select out of these 3? 701. The one which will be used very late. So how to see that particular, how to get that particular page is always use this reference string so that you will get a very clear idea which page will be used very late. Now look here, you are here and out of the 3 previous pages 107. Which one will be used very late? If you see here 0 is used immediately after this, then you can see 1 is appearing here, okay. That means the page that will be used very late is 7. 7 will be used very late, so we have to replace now 7. So in place of 7, 2 will appear, 0 and 1 will be as it is. In the next one, 0 is already there, there is a hit here now. So we'll write the letter H and then you write down as it is. Next 3 is not here, so there is a miss, okay. That means 3 means you are here now, okay. For this previous 3 page numbers are 201, okay. 201, out of this if you see in future which page will be used very late out of 201, 0 is used immediately, you should not replace, then 2 after that, then you can see 1 is used very late, so you can select 1 here to replace this. So what I'll do is to replace this one, to replace 1, this will be as it is, fine. Next there is a hit, 0 is already there, see you have to put 0, it is already there, there is a hit, so you have to write down 203. Next 4 is not there, now you have to see which one you will select to replace. So 4 you are presently here for 4, okay. Now you select 203, these 3 pages only, no, 2 is used immediately, after that 3 is used, then 0 is used late, so you can replace 0, you write down 2, 4, 3. And of course this was a miss because you did not had this page 4. Next is 2 is already there, this is a hit, so you can write down 2, 4, 3. 3 is already there here, you write down hit, okay, 2, 4, 3. Next is what? 0 is not there, but you have to select now one out of these 3, 2, 4, 3. Which one will you select? 0 means in this reference string you are here now, okay, you are here and you have to choose out of these 3, 2, 4, 3. So 3 is used immediately, 2 is after that, you should not replace. 4, yes, 4 is not there also in the string, so you can choose 4 here to replace. So what I'll do is in place of 4 I'll put 0, fine. So and the other 2 will be as it is. This was a miss, okay, this was a miss. Next is 3 is already there, it is a hit. Next is 2 is already there, there is a hit here, so write H. So it will be what? 203. Next is 1 is not there, now you have to select. So what you do is, this is what I am giving you the tip, always go to the reference string and see this one is what corresponding to this one now, this one present here, okay. Now you have to see to put this one inside the physical memory. Out of these 3, 203, 2 is used immediately, you should not replace, after that 0, 3 is not at all appearing in the scene, so better to select 3 now. So 201, and of course this was a miss, okay. Next is 2, 2 is already there. So it is a hit. First of all, I will write H, then 2, 0, 1. 0 is already there, it is a hit. So I will write as it is 2, 0, 1. 1 is already there, it is a hit. So it is 2, 0, 1. Next is 7. 7 means you are here now. Okay, here. And you have to select one out of these three. 0 and 1 are the only two pages here. 0 is used immediately after that 1. So 2 is not at all there. Better to select 2 now to replace the page. So you will write here 7, 0, 1. And of course this was a miss. 0 is already there. It is a hit. 7, 0, 1. 1 is already there. It is a hit. 7, 0, 1. Okay. So hope it is visible to you all. Okay. So this way you have solved the problem using the optimal page replacement algorithm. The page that will be used very late in future, that page has to be selected for replacement. So this way we have done. Now calculate the number of page faults. How to calculate the number of page faults? Simply calculate number of M here appearing. How many number of times the letter M is appearing? So here it is 1, 2, 3, 4, 5, 6, 7, 8, 9 times. The number of page faults is 9 here. Remember, number of page faults in this particular example is 9. And what about hit ratio and miss ratio? You can easily calculate. Number of hits are how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Number of hits are 11. And number of miss is definitely what? Number of page faults only. It is 9. 11 plus 9, totally it should come to 20. So this is what we have seen here. Out of the 20 page numbers that were appearing in the string, we got 9 page faults here. 9 page faults. And if you see this particular algorithm, if at all you have to see the features of this algorithm, just look here, the sentences I have written. The first line I have written about the logic only. Replace the page that will never be used for the longest period of time. Second line is difficult to implement. Why it is difficult to implement? Because it is very difficult to predict which page will be used very late by the CPU. That is not possible also. So that's why we say this algorithm is normally used only for comparison purpose. So we say no, for any type of solution, if at all we are interested, we always try to use the word optimal. Please give us an optimal solution. This way the name for this algorithm is optimal because it guarantees the lowest page fault rate. When it is compared with other algorithms, this algorithm guarantees the lowest page fault rate, but practically not possible to implement. It is only a theoretical, and also it can be used for comparisons purposes only. This is what is the optimal page replacement algorithm. If you find this session useful, please like, share and subscribe to my channel. Thank you. Bye bye. Take care.